Now we have this table. I didn't talk about how you actually do integration. Then how do I get this table? Very simple. You just differentiate the right part and see whether or not it gives you the left part. Then if that's true, that means this table is true. I define everything by differentiation. How do you know this is true? Well, because differentiate this guy ex is ex, we know from differentiation. And constant differentiation gives us 0. So this is true. Why we know this is true? Because we know from differentiation, differentiate sine x gives me cosine x, therefore this is true. This table comes from you knowing how to do differentiation. And with that, how do you do this? You don't know. And then you do differentiation, give you power 3. Then what? Probably you have to guess. Then you will say, oh, is this correct? Then you say, oh, this is x to power 4, or power is not the same. Then you change. So this is the first way, actually the stupid way. You guess and you do this without knowing how to do integration. The second way is you look at this table. How do you do integration? You just increase the power by 1 and divide by n plus 1. Cannot divide by 0. So this cannot be negative 1. So this is 3, it's not negative 1. So we just have 1 over 3 plus 1. So 4, and 3 plus 1 is 4. That's why. Done. Then what about this? Distribute inside. This is power 1. This is power 1 half. So we have 3 divided by 2. This is negative 2. This is power 1. So we have negative 1. This guy can split. Why? Because we can split. We split. The 2 can come out. Then we have this thing and this thing. This thing, n is not negative 1. So I can use this formula. So I have this thing. I just plus 1 and then power plus 1. This thing, here, I'm lazy. So I just use the high school formula and then saying this. So very strictly saying, this should be belong to, not equal. Okay? Okay, now what about the third one? For those who know high school calculus, you should use tangent or sine cosine substitution. But at this moment, I assume you don't know, so how should we approach this? You should make it as simple as possible. So what I'm going to do is plus 1 minus 1. Once I do this, this part and this part cancel out, give me 1. And the rest is 1 divided by 1 plus x, so I have this. So this one gives us x. And then this one, I'm sorry, you still need to know the sine cosine substitution. That's why this one we need to talk about later, which is actually I'm using the formula here. That means if you know this formula, you know how to get from here to here. If you don't know this formula, doesn't matter. You can say let x equal, let's say, tangent theta, and then do the sine cosine substitution, which is not now, but later. Now, the first trick, change of variable. Suppose I have to integrate this. This one is tricky. You cannot say I multiply this into a polynomial and then do the calculation as usual. You do a Taylor expansion of this square root. Then you have a bunch of polynomial, and then you multiply the x inside the Taylor expansion, and then you integrate them one by one, and then finally you get a bunch of terms, and then you look at their pattern and you go back. You can, but that is tedious. Nobody will do it. So this is the better way. So what I'm going to do is I let t become this thing. Why? Because square root thing inside is the thing that is difficult. So you start with the difficult thing. I let t equal this thing. So this term is my whole term. Then what? Then I can say dx, right? Then 2x, that's it. And then therefore, that means dt dx is 2x. And then I move this to the other side. So dt is 2x dx. So I have this green box. Now I'm going to use the trick. So first, I have my yellow thing as t. So yellow thing become t, okay? And then my dt is 2 dx, x dx. Then I create a 2 here and divide by 2. That's what I do. Create a 2 here, divide by 2. 2x dx is green box, become dt. So I can integrate this. This is what? This is exactly formula. Power, not negative 1. Then I can get this. Finally, I have t, but my question is on x. Then I call back the yellow box. T is x squared plus 4. So this power 3 divided by 2 become x squared plus 4. That's how you deal with substitution. Second example, integrate 2x and then e and then power of x, and the x also have a power. The hard part is this thing. Then I am going to set t is my hard part. Then what I'm going to do? Well, I repeat the procedure. Then dt dx is this guy, ddx is 2x, so t is 2x dt dx. So I have this green thing. Then what I'm going to do is to find this green thing in my expression. This is the green thing. Okay, so I have this. So I have everything in t. Integrate et is itself. Again, the chicken and duck symbol, I can draw a chicken and a duck here, right? This x is just a dummy variable. So this is exactly the same thing. So I have et, and then again, this is on x. I'm now in t. I need to go back. So I put it back. So I get this. Log x divided by x. And since we know that d log x is 1 over x. So therefore, this gives us a hint. Here, what I do is d log x is 1 over x dx, right? 1 over x dx is log d log x, so I have d log x. So now we have this term. This log x is just a symbol. The chicken and duck thing. I can draw a chicken here, I can draw a duck here. So this is an integration duck d duck, which I call t, okay? Then I have this. This is easy. It's just half t squared plus c. And then I go back because I let t equal log x, so I go back, so I get this. Okay, now I go to this one. This square root x is the troublemaker. Then what you do, you start with t encapsulating the square root, because square root is the thing that makes this integration hard. So you include the square root inside t. And now you will get x equal t squared, right? Why you need to do this? Because you want to get dx something. So from here, x equal t squared. So dx dt is 2t. So dx is 2t dt. So dx is 2t dt. So dx is 2t dt. And then t is square root x. This is square root x. This is square root x. So now I have everything like this. And then now from here, okay, I have what? 2t 1 over t, right? Then what I'm going to do? Well, right? I can put a bracket, right? I can do this, right? So I get what? 2, the 2 I take out, so I have a 2 here. T plus 1 minus 1. And then this part is 1. So I have a 2, 1. And then the remaining part is minus 1, 1 plus t, right? So I have this part. That's how I get this. The 2 distribute inside. So now I have this thing. Then this is just integration dt. Okay, usually there's a 1 here, but we don't write down. This means what? This means t to power 0. Recap. It didn't say you cannot be 0. You can be 0, right? It's just not negative 1. So integration t power 0 is t plus 1, and then divide by 0 plus 1. So basically it's t plus c. Okay, so this is the first term. Then what about the second term? That means this one. So the second term you have negative 2, negative, and then 1 over t dt, right? Okay, now I'm going to do change of variable again. I let u is t plus 1. Then du dt is this thing, right? Which is constant, I don't care. This is giving me 1, right? So I have 1. Put this to the other side, so du is dt. So therefore, now this thing is u, this is du. So the whole thing is log u. Again, I use a easy one, so this actually should belong to. And I have negative 2, so I put negative 2 here. This is in u, but I need to go back to t, so negative 2 log t plus 1. So that's why this part gives me this part. This is everything in t, but my original is everything in x. So now I have 2 square root x, and then 2 log 1 plus square root x plus c. And if I want to make it absolutely straight, this should belong to not equal.